Embedded application development. Learning objectives. In this chapter, the user would learn the following aspects of embedded application development: design methodologies, embedded database applications, voice over IP, mobile Java applications, design examples. UML as design tool. UML is a standard language for specifying, visualizing, constructing, and documenting the artifacts of software systems. OMG is continuously putting effort to make a truly industry standard. UML stands for Unified Modeling Language. UML is different from the other common programming languages like C++, Java, COBOL, etc. UML is a pictorial language used to make software blueprints. UML goals. A picture is worth 1,000 words. This absolutely fits while discussing about UML. Object-oriented concepts were introduced much earlier than UML. So at that time, there were no standard methodologies to organize and consolidate the object-oriented development. At that point of time, UML came into picture. There are a number of goals for developing UML, but the most important is to define some general purpose modeling language which all modelers can use, and also it needs to be made simple to understand and use. UML diagrams are not only made for developers but also for business users, common people, and anybody interested to understand the system. The system can be a software or non-software. So it must be clear that UML is not a development method, rather it accompanies with processes to make a successful system. A conceptual model of UML. A conceptual model can be defined as a model which is made of concepts and their relationships. A conceptual model is the first step before drawing a UML diagram. It helps to understand the entities in the real world and how they interact with each other. As UML describes the real-time systems, it is very important to make a conceptual model and then proceed gradually. Conceptual model of UML can be mastered by learning the following three major elements: UML building blocks, rules to connect the building blocks, common mechanisms of UML. UML building blocks. As UML describes the real-time systems, it is very important to make a conceptual model and then proceed gradually. Conceptual model of UML can be mastered by learning the following three major elements: UML building blocks, rules to connect the building blocks, common mechanisms of UML. This chapter describes all the UML building blocks. The building blocks of UML can be defined as things, relationships, diagrams. Object-oriented concepts. Objects represent an entity and the basic building block. Class. Class is the blueprint of an object. Abstraction. Abstraction represents the behavior of a real-world entity. Encapsulation. Encapsulation is the mechanism of binding the data together and hiding them from outside world. Inheritance. Inheritance is the mechanism of making new classes from existing ones. Polymorphism. It defines the mechanism to exist different forms. UML notation. UML notations are the most important elements in modeling. Efficient and appropriate use of notations is very important for making a complete and meaningful model. Graphical notations used in structural things are the most widely used in UML. List of structural things: classes, interface, collaboration, use case, active classes, components, nodes. Class notation. Class diagram notation is divided into four parts: name, attributes, operations, additional components. Object notation. The object is represented in the same way as the class. The only difference is the name, which is underlined as shown. An object is the actual implementation of a class, which is known as the instance of a class. Interface notation. Interface is represented by a circle. Interface is used to describe functionality without implementation. Collaboration notation. Collaboration is represented by a dotted ellipse. It has a name written inside the ellipse. Use case notation. Use case is represented as an ellipse with a name inside it. It may contain additional responsibilities. Use case is used to capture high-level functionalities of a system. Actor notation. An actor can be defined as some internal or external entity that interacts with the system. Actor is used in a use case diagram to describe the internal or external entities. Initial state notation. Initial state is defined to show the start of a process. The notation is used in almost all diagrams. The usage of initial state notation is to show the starting point of a process. Final state notation. Final state is used to show the end or termination of a process. This notation is also used in almost all diagrams. Active class notation. Active class looks similar to a class with a solid border. Active class is generally used to describe concurrent behavior of a system. Component notation. A component in UML is shown with a name inside. Node notation. A node in UML is represented by a square box as shown with a name. A node represents a physical component of the system. Behavioral things. Dynamic parts are one of the most important elements in UML. UML has a set of powerful features to represent the dynamic parts of software and non-software systems. These features include interactions and state machines. Interaction notation. Interaction is basically message exchange between two UML components. Interactions can be of two types, that is sequential, represented by sequence diagram, and collaborative, represented by collaboration diagram. State machine notation. State machine describes the different states of a component in its life cycle. The state can be active, idle, or any other depending upon the situation. Grouping things. Organizing the UML models are one of the most important aspects of the design. In UML, there is only one element available for grouping, and that is package. Package notation. Package notation is shown below, and this is used to wrap the components of a system. Notational things. In any diagram, explanation of different elements and their functionalities. Note notation. This notation provides necessary information of a system. Relationships. A model is not complete unless the relationships between elements. The different types of relationships available in UML are dependency, association, generalization, extensibility. Dependency notation describes the dependent elements and the direction of dependency. Dependency is represented by a dotted arrow. The arrowhead represents the independent element and the other end the dependent element. Association notation. Association describes how the elements in a UML diagram are associated. In simple words, it describes how many elements are taking part in an interaction. Association is represented by a dotted line with or without arrows on both sides. The multiplicity is also mentioned at ends, 1, star, etc. to show how many objects are associated. Association is used to represent the relationship between two elements of a system. Generalization notation. Generalization describes the inheritance relationship of the object-oriented world. It is a parent and child relationship. Extensibility notation. All the languages, programming or modeling, have some mechanism to extend its capabilities like syntax, semantics, etc. UML is also having the following mechanisms to provide extensibility features. Stereotypes represents new elements. Tagged values represents new attributes. Constraints represents the boundaries. Extensibility notations are used to enhance the power of the language. Requirement analysis and use case modeling. Use case model is implemented based on following requirements. Use case diagram, an overview of the system. Use case description, details about each function. More will be provided later. Actors and use cases. An actor is something that performs use cases upon a system. An actor is just an entity, meaning it can be a human or other artifacts that directly play an external role in the system, as long as they either directly use the system or is used by the system. For each use case, we have to know entry conditions, that is precondition, and exit conditions, post conditions. So basically, what is true before the use case and what is true after the use case. Software development methods. UML was designed to be compatible with the leading object-oriented software development methods of its time. Modeling. Graphic representation of a system's model. The model may also contain documentation that drives the model elements and diagrams. UML diagrams represent two different views of a system model. Static or structural view emphasizes the static structure of the system using objects, attributes, operations, and relationships. The structural view includes class diagrams and composite structure diagrams. Dynamic or behavioral view emphasizes the dynamic behavior of the system by showing collaborations among objects and changes to the internal states of objects. This view includes sequence diagrams, activity diagrams, and state machine diagrams. UML models can be exchanged among UML tools by using the XML metadata interchange, XMI interchange. Static modeling. Class diagram. The class diagram is a static diagram. It represents the static view of an application. Class diagram is not only used for visualizing, describing, and documenting different aspects of a system, but also for constructing executable code of the software application. Following points should be remembered while drawing a class diagram. The name of the class diagram should be meaningful to describe the aspect of the system. Each element and their relationships should be identified in advance. Responsibility, attributes, and methods of each class should be clearly identified. For each class, minimum number of properties should be specified. Use notes whenever required to describe some aspect of the diagram. Object diagram. Object diagrams represent an instance of a class diagram. The basic concepts are similar for class diagrams and object diagrams. Object diagrams also represent the static view of a system, but this static view is a snapshot of the system at a particular moment. Object diagrams are used for making the prototype of a system, reverse engineering, modeling complex data structures, understanding the system from practical perspective. Component diagram. Component diagrams are used to visualize the physical components in a system. A single component diagram cannot represent the entire system, but a collection of diagrams are used to represent the whole. Purpose of the component diagram. Visualize the components of a system, construct executable by using forward and reverse engineering, describe the organization and relationships of the components. Deployment diagram. Deployment diagrams are used to visualize the topology of the physical components of a system where the software components are deployed. UML is mainly designed to focus on software artifacts of a system. UML diagrams are used to handle logical components, but deployment diagrams are made to focus on hardware topology of a system. Deployment diagrams are used by the system engineers. Usage of deployment diagrams. To model the hardware topology of a system, to model embedded system, to model hardware details for a client or server system, to model hardware details of a distributed application. Composite diagram. A composite structure diagram is a diagram that shows the internal structure of a classifier, including its interaction points to other parts of the system. A part is an element that represents a set of one or more instances which are owned by a containing classifier instance. The ports define the interaction between a classifier and its environment. An interface is similar to a class but with a number of restrictions. A delegate connector is used for defining the internal workings of a component's external ports and interfaces. A collaboration defines a set of cooperating roles used collectively to illustrate a specific functionality. Sequence diagram. Sequence diagram, lifeline, execution specification, message combined, fragment, interaction use, state invariant, continuation, destruction, occurrence. Lifeline is a named element which represents an individual participant in the interaction. Message is a named element that defines one specific kind of communication between lifelines of an interaction. Activity diagram. Activity diagram is basically a flow chart to represent the flow from one activity to another activity. It captures the dynamic behavior of the system. Activity diagrams are not only used for visualizing dynamic nature of a system, but they are also used to construct the executable system by using forward and reverse engineering techniques. It shows different flows like parallel, branched, concurrent, and single. Activity diagram, we should identify the following elements: activities, association, conditions, constraints. Static machine. State machine diagram is a behavior diagram which shows discrete behavior of a part of design system through finite state transitions. State machine diagrams can also be used to express the usage protocol of part of a system. Two kinds of state machines defined in UML 2.4 are behavioral state machine, protocol state machine. Collaboration diagram. Collaboration diagram. The method call sequence is indicated by some numbering technique. The number indicates how the methods are called one after another. The method calls are similar to that of a sequence diagram. If the time sequence is important, then sequence diagram is used, and if organization is required, then collaboration diagram is used. Difference between static and dynamic model. Static modeling is used to specify structure of the objects that exist in the problem domain. These are expressed using class, object, and use case diagrams. Example, class has same number of students in a year. Dynamic modeling refers representing the object interactions during runtime. It is represented by sequence, activity, collaboration, and state chart diagrams. Example, ATM can accept card only when it is in ready state. ATM cannot read card when it is in error state. Thus, state of ATM is a dynamic aspect. Embedded system. An embedded system is a computer system with a dedicated function within a larger mechanical or electrical system, often with real-time computing constraints. It is embedded as part of a complete device, often including hardware and mechanical parts. Database. A database is an organized collection of data. The data are typically organized to model relevant aspects of reality in a way that supports processes requiring this information. Database management systems, DBMSs, are specifically designed software applications that interact with the user, other applications, and the database itself to capture and analyze data. An embedded database system is a database management system, DBMS, which is tightly integrated with application software that requires access to stored data. Database system is hidden from the application's end user and requires little or no ongoing maintenance. Embedded database products are used in real-time embedded systems such as telecommunication switches and consumer electronic devices. A general-purpose DBMS is a software system designed to allow the definition, creation, querying, update, and administration of databases. MySQL as an embedded database. Over 2,000 ISVs, OEMs, and VARs rely on MySQL as their product's embedded database to make their applications, hardware, and appliances more competitive, bring them to market faster, and lower their COG, that is, cost of goods sold. These ISV and OEM customers choose MySQL for its low cost, up to 90% less than Microsoft SQL Server, with features that ensure COGs remain low throughout an application's lifecycle. Lower database costs allow vendors to offer their products at a fraction of the cost of competing solutions and the flexibility to appeal to more price-sensitive customers. Cross-platform flexibility. With support for over 20 platforms providing the freedom to ship products on multiple hardware and operating system combinations and into more markets. High performance, reliability, and scalability. A full-featured RDBMS helps to make products more competitive initially and over time as customers' data needs inevitably increase. Zero administration, eliminating the need for customers to hire a dedicated DBA or spend any cycles on database administration, and reducing or eliminating costly database-related support calls. Oracle's embeddable databases. Fast installation, configuration, and integration lets developers focus on developing applications, reducing costs, and shortening time to market. Fast, scalable, and reliable choice for mission-critical edge applications operating outside the data center. Silent database installation and configuration, a key differentiator for applications that manage data and run unattended. Broad range of proven commercial off-the-shelf products draw upon deep database management expertise and reduce product development cycle time, cost, and risk. Deep Oracle partner ecosystem provides superior support, training, and ongoing maintenance benefits. Examples of embedded databases. Desktop email software, Microsoft Outlook PST files, Thunderbird stores mail in multiple files that make up the data and indexes. Apple Mail uses an embedded database. Desktop search, Google Desktop, Beagle, Live Search. The desktop search market heavily uses local databases to store file data, search indexes, and more. BlackBerry smartphones. The BlackBerry is actually a giant Oracle database. The entire file system is stored in an embedded database. Desktop applications that embed Microsoft Access MDB files. Many use the Access runtime for their data store but display icons and logos from their own application. Many small business packages are written as Access modules. Games. Games are storing more and more data into embedded databases to allow quicker stats generation or even as save game formats. Accounting packages. Most accounting packages like QuickBooks store their records in relational data for ease of reporting and quick retrieval of records based upon criteria. Microsoft Money files are also an embedded database. Tax systems. Applications like TurboTax store often user entries in an embedded database for quick cross-reference and tabular access to the results. Switches or routers, DNS entities, DHCP data, and even just the user configuration settings are often stored in databases. Blogs. Almost every popular blogging system uses some form of database to put the blog and comment data. Graphity is an example that uses VistaDB to store the data with the blog for quick FTP deployment of the blog presentation and data. Embedded database application. VistaDB resides with your application and executes in process with your application. The database files are a single file, VDB3 file, that may be renamed in order to be used as a file format for your application. The VistaDB runtime assembly is a single .NET assembly that may be merged into your application to further disguise the use of our database within your application. Voice over Internet Protocol, VoIP, is a methodology and group of technologies for the delivery of voice communications and multimedia sessions over Internet Protocol networks such as the Internet. VoIP are IP telephony, Internet telephony, voice over broadband, VoBB, broadband telephony, IP communications, and broadband phone service. The steps and principles involved in originating VoIP telephone calls are similar to traditional digital telephony and involve signaling, channel setup, digitization of the analog voice signals, and encoding. Instead of being transmitted over a circuit-switched network, however, the digital information is packetized and transmission occurs as Internet Protocol packets over a packet-switched network. Early providers of Voice over Internet Protocol services offered business models and technical solutions that mirrored the architecture of the legacy telephone network. Second generation providers such as Skype have built closed networks for private user bases, offering the benefits of free calls and convenience while potentially charging for access to other communication networks such as PSTN. Third generation providers such as Google Talk have adopted the concept of federated VoIP, which is a departure from the architecture of the legacy networks. VoIP systems employ session control and signaling protocols to control the signaling, setup, and tear down of calls. They transport audio streams over IP networks using special media delivery protocols that encode voice, audio, video with audio codecs, and video codecs as digital audio by streaming media. Various codecs exist that optimize the media stream based on application requirements and network bandwidth. Some implementations rely on narrow band and compressed speech, while others support high fidelity stereo codecs. Some popular codecs include MuLaw and A-Law versions of G711, G722, which is a high fidelity codec marketed as HD Voice by Polycom, a popular open source voice codec known as ILBC, a codec that only uses 8 kbit per second each way, called G729, and many others. VoIP is available on many smartphones, personal computers, and on internet access devices. Calls and SMS text messages may be sent over 3G or Wi-Fi. Voice over Internet Protocol has been implemented in various ways using both proprietary protocols and protocols based on open standards. Examples of the VoIP protocols are H323, Media Gate Control Protocol, MGCP, Session Initiation Protocol, SIP, H248, also known as Media Gateway Control, Megaco, Real-Time Transport Protocol, RTP, Real-Time Transport Control Protocol, RTCP, Secure Real-Time Transport Protocol, SRTP, Session Description Protocol, SDP, Inter-Asterisk Exchange, IAX, Jingle XMPP VoIP extensions, Skype Protocol, TeamSpeak. The H323 protocol was one of the first VoIP protocols that found widespread implementation for long-distance traffic as well as local area network services. However, since the development of newer, less complex protocols such as MGCP and SIP, H323 deployments are increasingly limited to carrying existing long-haul network traffic. In particular, the Session Initiation Protocol, SIP, has gained widespread VoIP market penetration. Adoption. Consumer market. Phone calls between subscribers of the same provider are usually free when flat fee service is not available. A VoIP phone is necessary to connect to a VoIP service provider. This can be implemented in several ways. Dedicated VoIP phones connect directly to the IP network using technologies such as wired Ethernet or Wi-Fi. They are typically designed in the style of traditional digital business telephones. PSTN and mobile network providers. It is becoming increasingly common for telecommunications providers to use VoIP telephony over dedicated and public IP networks. To connect switching centers and to interconnect with other telephony network providers, this is often referred to as IP backhaul. Smartphones and Wi-Fi enabled mobile phones may have SIP clients built into the firmware or available as an application download. Corporate use. VoIP solutions aimed at businesses have evolved into unified communication services that treat all communications, phone calls, faxes, voicemail, email, web conferences, and more as discrete units that can all be delivered via any means and to any handset, including cell phones. Two kinds of competitors are competing in this space. One set is focused on VoIP for medium to large enterprises, while another is targeting the small to medium business market. VoIP allows both voice and data communication to be run over a single network, which can significantly reduce infrastructure costs. Corporate use. Dual mode phones enable users to continue their conversations as they move between an outside cellular service and an internal Wi-Fi network. Skype, which originally marketed itself as a service among friends, has begun to cater to businesses, providing free of charge connections between any users on the Skype network and connecting to and from ordinary PSTN telephones for a charge. Security. The security concerns of VoIP telephone systems are similar to those of any internet-connected device. This means that hackers who know about these vulnerabilities can institute denial of service attacks, harvest customer data, record conversations, and compromise voicemail messages. Government and military organizations use various security measures to protect VoIP traffic, such as Voice over Secure IP or VoSIP, Secure Voice over IP, SVOIP, and Secure Voice over Secure IP, SVOSIP. Quality of service. Communication on the IP network is perceived as less reliable in contrast to the circuit-switched public telephone network because it does not provide a network-based mechanism to ensure that data packets are not lost and are delivered in sequential order. It is a best effort network without fundamental quality of service guarantees. Network routers handle traffic on a first-come, first-served basis. Network routers on high-volume traffic links may introduce latency that exceeds permissible thresholds for VoIP. Fixed delays cannot be controlled as they are caused by the physical distance the packets travel. However, latency can be minimized by marketing voice packets as being delay-sensitive with methods. What is Java? Java is a very popular programming language developed by Sun Microsystems. Still, programming languages are only as powerful as their libraries. These libraries exist to help developers build applications. Java's important core features are: it is easy to learn and understand, it's designed to be platform independent and secure using virtual machines. It is object-oriented. What is a J2ME configuration? J2ME Connected Limited Device Configuration (CLDC) specifies the Java environment for mobile phone, pager, and wireless devices. CLDC devices are usually wireless. 160 to 512K of memory available for Java. Typically has limited power or is battery operated. Network connectivity often wireless, intermittent, low bandwidth, 9600 bps or less. J2ME Connected Device Configuration (CDC) describes the Java environment for digital television set-top boxes, high-end wireless devices, and automotive telematics systems. Device is powered by a 32-bit processor. 2 MB or more of total memory available for Java. Network connectivity often wireless, intermittent, low bandwidth, 9600 bps or less. Application development. Midlets are applets for mobile phones. Just like applets, they run in a protected sandbox, the KVM, but unlike applets, they are extremely limited. MIDP 1.0 is currently found on most Java-capable phones and is fairly restrictive. As an example, the KVM doesn't allow you to process floating point numbers yet, and midlets written for MIDP 1.0 can't access anything outside of the sandbox without proprietary APIs from phone manufacturers. So, put your dreams of developing the ultimate midlet with hooks into every part of your phone OS on the back burner for a while. If you want to find out exactly how limited MIDP 1.0 is, you should probably read the spec here. Once you have done that, you might want to check out MIDP 2.0 and see what Sun has fixed with that spec. Create sample application. Open NetBeans and create a new mobile device application. Reference ASPOS barcode. Please refer to setting the environment for information on how to prepare the development environment and adding reference to the ASPOS barcode J2ME jar package. As mentioned in setting the environment, after creating a new project, A hello midlet Java file is created by the product wizard. The screen contains a default screen item with the text hello world. Right-click the screen item and select delete to remove it. The screen is now empty without controls. Right-click the screen and select new or add followed by text field from the menu. A text field control is added. Go to the screen view of the main form and drag an item command onto it. Set the label to generate barcode. Go to the flow view of the form, right-click the blank area and select the new or add followed by call point. A new call point is created. Right-click it and choose properties from the menu. In call code, specify generate barcode, open brace, close brace, semicolon. Connect the newly added item command to this call point. Method to generate the barcode and render on-device screen. Build and run the application. If there is no build error, the emulator opens and the application loads. Enter any value in the code text field. Click the menu and select generate barcode. The PDF 417 barcode image is rendered on the screen. Example, first the user needs to log in and start a session. Then on the mobile device, he records any notes or comments he has on that product during real-time usage. At any time, the user can send the timestamp notes to a central database for further processing. Telephone PBX. A PBX, private branch exchange, is a telephone system within an enterprise that switches calls between enterprise users on local lines while allowing all users to share a certain number of external phone lines. The main purpose of a PBX is to save the cost of requiring a line for each user to the telephone company's central office. The PBX is owned and operated by the enterprise rather than the telephone company, which may be a supplier or service provider. However, private branch exchanges used analog technology originally. Today, PBXs use digital technology. Digital signals are converted to analog for outside calls on the local loop using plain old telephone service, POTS. Telephone PBX. Telephone trunk, multiple phone lines that terminate at the PBX. A computer with memory that manages the switching of the calls within the PBX and in and out of it. The network of lines within the PBX. A console or switchboard for a human operator, optional. In some situations, alternatives to a PBX include centric service, in which a pool of lines are rented at the phone company central office, key telephone systems, and for very small enterprises, primary rate integrated services, digital network, ISDN. Lucent Technologies, Northern Telecom, Nortel, ROLM, Siemens, NEC, GTE, Inticom, Fujitsu, Hitachi, and Mittal are among the large manufacturers of PBX. Set-top box. A set-top box, STB, or set-top unit, STU, is an information appliance device that generally contains a TV tuner input and displays output connects to a television set and an external source of signal, turning the source signal into content in a form that can be displayed on the television screen or other display device. They are used in cable television, satellite television, and over-the-air television systems, as well as other uses. TV signal sources, a consumer Qualcomm DSL 350 satellite receiver. The IF demodulation tuner is on the bottom left and a Fujitsu MPEG decoder CPU is in the center of the board. The power supply is on the right. The signal source might be an Ethernet cable, a satellite dish, a coaxial cable, see cable television, a telephone line including DSL connections, broadband over power lines, BPL, or even an ordinary VHF or UHF antenna. Content in this context could mean any or all of video, audio, internet web pages. UHF converter. UHF converter would be installed at the receiver to shift a portion of the UHF TV spectrum onto low VHF channels for viewing. Cable converter. Cable television represented a possible alternative to deployment of UHF converters, as broadcasts could be frequency shifted to VHF channels at the cable head end instead of the final viewing location. However, most cable systems could not accommodate the full 54890 MHz VHF or UHF frequency range, and the 12 channels of VHF space were quickly exhausted on most systems. Closed captioning box. Set-top boxes were also made to enable closed captioning on older sets in North America before this became a mandatory inclusion in new TV sets. Digital television adapter. The transition to digital terrestrial television after the turn of the millennium left many existing television receivers unable to tune and display the new signal directly. ATM system. An automated teller machine or automatic teller machine, also known as automated banking machine, cash point, cash line, or colloquially hole in the wall, is an electronic telecommunications device. On most modern ATMs, the customer is identified by inserting a plastic ATM card with a magnetic stripe or a plastic smart card with a chip that contains a unique card number and some security information such as an expiration date and personal identification number, PIN. ATM is typically made up of the following devices: CPU to control the user interface and transaction devices, magnetic or chip card reader to identify the customer, PIN pad EEP4, similar in layout to a touch tone or calculator keypad, manufactured as part of a secure enclosure, display used by the customer for performing the transaction, function key buttons, usually close to the display, or a touchscreen used to select the various aspects of the transaction, record printer to provide the customer with a record of the transaction, vault to store the parts of the machinery requiring restricted access, housing for aesthetics and to attach signage to sensors and indicators. Washing machine. A washing machine, laundry machine, clothes washer or washer is a machine to wash laundry such as clothing and sheets. The term is mostly applied only to machines that use water as opposed to dry cleaning, which uses alternative cleaning fluids and is performed by specialist businesses or ultrasonic cleaners. Washing entails immersing, dipping, rubbing, or scrubbing in water, usually accompanied by detergent or bleach. The simplest machines may just agitate clothes in water. Automatic machines may fill, empty, wash, spin, and heat in a cycle. Most washing machines remove substantial amounts of water from the laundry at the end of a wash cycle but do not completely dry it. Conclusion. In this chapter, the user has covered the following aspects of embedded application development: design methodologies, embedded database applications, voice over IP, mobile Java applications, design examples.